Okay, let's unpack this. Welcome to the Deep Dive, where we slice through complex topics and give you the essential insights you need to be truly well-informed. Today we're plunging into a new, frankly surprising shift in the world of artificial intelligence. For so long, the conversation around AI has been dominated by the idea of massive, resource-hungry models. But our sources for this deep dive reveal a fascinating, almost counterintuitive future. Our mission for you today is to understand how incredibly small, yet profoundly powerful, self-improving AI agents are poised to redefine knowledge work across virtually every industry. We're going to dissect how these agents fundamentally differ from the large AI models we hear about constantly, and crucially, why that difference matters profoundly for you and for the very future of how work gets done.
And what's truly revolutionary here is precisely that counter-narrative, that intellectual pivot. For years, the prevailing wisdom in AI development has been a relentless pursuit of scale. More parameters, more data, more compute. The thinking was bigger equals better, leading to more intelligence or at least more apparent capability. But the research and insights we've curated point to the emergence of something different, something being termed microscale superintelligent, rapidly and autonomously self-improving ANDSI agentic AIs. Whew, that's a mouthful.
It is a mouthful.
ANDSI agents.
Yeah, ANDSI agents. And this isn't just an incremental improvement on existing AI. It represents a fundamental rethinking of AI architecture and capability. It's a philosophical shift, really. Moving from brute force generalization to hyper-specialized efficiency. It's like a profound decentralization of advanced AI power.
And that profound philosophical shift is exactly where we need to start this deep dive. Because for the last few years, if you followed any tech news at all, you know the dominant narrative. It's been all about massive LLMs, right? Large language models. Right. The giants.
Exactly. When you hear about breakthrough AI capabilities, whether it's generating human-like text, translating languages, or even writing code, the underlying engine is almost always one of these huge models. We're talking billions, often hundreds of billions, sometimes even trillions of parameters. Think GPT-3, GPT-4, or their counterparts from, all the big tech players.
Absolutely. And these models are incredibly resource intensive, almost, well, astronomically so.
Yeah, astronomically is a good word. They consume truly vast amounts of data for training, like pretty much the entire digitized internet.
Right.
Billions upon billions of tokens of text and code.
Which translates directly into staggering computational demands.
Exactly. Massive data centers packed with specialized hardware, GPUs everywhere, using enormous amounts of energy.
Equivalent to powering small cities.
All right. And the financial costs. Just mind-boggling, both to train them in the first place and then just to run them day to day. So you, our listener, can probably already see the implications here. It limits who can access this tech, right?
Definitely.
There are big environmental concerns about the energy use, and it inevitably concentrates power and capability with just a few tech giants who can actually afford this kind of infrastructure.
And this is precisely where the revolutionary pivot described in our sources comes into play. We're talking about a fundamental, almost shocking shift towards what are described as super fast, low energy, low cost, microscale, self-improving ANDSI models.
Microscale, that's the key word.
Exactly. And if we connect this to the bigger picture, it's far more than just a slight improvement in efficiency or, cutting costs. It's a foundational change in the very philosophy of AI design and deployment. Instead of just building bigger and bigger generalist models that try to do everything, write poems, diagnose diseases, maybe not always perfectly.
Yeah, jack of all trades, master of none sometimes.
Kind of. These new approaches focus intently on specialized, efficient intelligence. That's what NDSI stands for, Artificial Narrow Domain Superintelligence. And that narrow domain part is absolutely critical here.
Okay, so break that down. Narrow domain versus the LLMs.
Right. Unlike those massive LLMs designed to understand, pretty much everything, these ANDSI agents are explicitly engineered to be supremely excellent, truly superintelligent, but only at specific tasks. Within a very defined, contained, often highly specialized area, they don't aim for broad general knowledge.
They aim for mastery in a niche.
Precisely. Unparalleled mastery. Which means they aren't just smaller LLMs. They represent a totally distinct architectural and philosophical path for AI.
So if we're trying to visualize this, maybe it's like moving from a giant sprawling library with every book ever, but finding the specific paragraph you need takes forever.
Yeah, and maybe the librarian is a bit overwhelmed.
Right, and we're shifting towards like a highly specialized expert consultant. They only know about, say, 18th century French poetry, but they know everything about it instantly.
That's a great analogy. Compact ANDSI agents. They don't know everything, but what they know with incredible depth and efficiency.
Now, here's where it gets really genuinely interesting. This profound shift isn't just happening by accident. It's not one single breakthrough. Our sources reveal it's driven by a unique synergy, right? A convergence of three distinct cutting-edge innovations developing in parallel.
Exactly. 3 pillars, you could say. Each one is remarkable on its own, addressing a different key challenge in AI.
But it's how they work together that's the magic here.
That's it. Their interaction, their working in concert, creates something far more powerful than the sum of its parts. It's what's catalyzing this new era of microscale AI.
Okay, it sounds like maybe 3 different scientific fields suddenly finding common ground and unlocking something totally new.
That's a good way to put it. They tackle things like the massive computational demands, the difficulty in getting true abstract reasoning from limited data, and the challenge of building, really reliable and interpretable knowledge into AI. Their synergy unlocks capabilities we thought needed that brute force scale. That's why it's such a huge paradigm shift.
Okay, let's dive into these 3 foundational pillars making this microscale revolution possible. What's the first one? Pillar number 1, GAIR-NLP's ASI-Arch. Okay, the name, Artificial Superintelligence Architecture, sounds pretty grand.
It is ambitious, yeah.
But its core function is, well, kind of mind-bending, self-designing architectures. Normally, you think of human engineers designing the AI structure, right? The neural network, how it all fits together. So for our listener, what does it mean for an AI to self-design its own architecture? Can you give us an analogy?
It's a huge leap. I mean, it takes the human out of a really fundamental part of the design loop. Imagine not just an architect who designs great buildings, but an architect who somehow designs better ways to design buildings.
Okay, like they're optimizing their own tools and processes constantly.
Exactly. Constantly optimizing their own tools, their blueprints, their whole design philosophy, iterating on how they create. That's basically what GAIR-NLP's ASI-Arch does for AI models. It's an AI that learns how to invent better AI architectures. It's meta-learning.
Wow. And why is that so significant?
Well, it means these systems can discover novel, highly optimized designs that maybe human engineers wouldn't even think of or wouldn't find easily. The sources highlight ASI-Arch already discovered 106 state-of-the-art linear attention models.
Okay, linear attention. That sounds technical. Why is that important, especially for microscale AI?
Good question. So traditional attention mechanisms in those big LLMs, super powerful, let the AI weigh what's important in the input. But they're computationally intensive. They scale quadratically with the input length, meaning more info, the cost explodes.
Okay, so not good for small, efficient agents.
Not at all. Linear attention is a more efficient variant. It still lets the model focus effectively, but the computational cost scales linearly. Much, much better. This efficiency is absolutely crucial for microscale operation. You need lean internal mechanisms.
Right, so ASI-Arch finds these super efficient linear attention structures.
Exactly. It uses techniques like low-rank approximations or specialized recurrent mechanisms to achieve that linearity. It drastically cuts the computational load but keeps a lot of the power.
Huh.
So this self-designing ability means the AIs can invent their own best internal structures, tailor-made for efficiency and performance, not just relying on human designs, which might be suboptimal. It's like automated meta-engineering, pushing the limits of low-compute AI.
That's truly a game changer. An AI building better, more efficient AI. But efficiency is only half of it, right?
Yeah.
They also need serious intelligence, and usually we think that means huge scale. But the next piece here from Sapient seems to challenge that idea completely. Sapient's HRM architecture, what jumps out immediately is the size. 27 million parameters.
Yeah, 27
Now,
million.
we were just talking billions or trillions. 27 millions is tiny, orders of magnitude smaller. So the obvious question is, how can something that small be so powerful, so smart?
It's astonishingly counterintuitive, isn't it? Sapient's HRM architecture's core capability is achieving strong abstract reasoning like ARC-AGI with this incredibly tiny footprint.
ARC-AGI, remind us what that is.
Right. So ARC-AGI, the Abstract Reasoning Corpus Artificial General Intelligence Benchmark. It's not just about spotting patterns in tons of data. It's a really tough test for genuine, human-like abstract problem solving, understanding underlying rules, figuring out general principles from just a few examples, and then applying them to new situations. Real generalization.
Okay, so true reasoning, not just fancy pattern matching.
Exactly. And the truly mind-boggling part, HRM does this with just 1,000 examples and no pre-training.
1,000 examples and no pre-training. compared to the billions of tokens LLMs need.
Stark contrast, isn't it? Those massive LLMs learn by basically seeing almost everything, hoping to infer relationships. It takes incredible time and energy. Sapient's HRM shows high-level intelligence from a tiny fraction of the data without that hugely expensive pre-training step.
Wow. So what does that suggest?
Well, what's fascinating here is that it points to a completely different, much more efficient, maybe even more robust path to AI capability. One that learns more like, well, maybe more like a human. Abstracting general principles from fewer examples, not just statistical correlations from a data ocean. This slashes the data and compute overhead we thought was necessary for this kind of thinking. Perfect for microscale agents.
That's a huge shift, learning abstract concepts from way fewer examples. Which leads us perfectly to pillar number 3, Princeton's bottom-up knowledge graph approach. This sounds different again, like building intelligence on a really solid foundation.
That's a good way to think about it, a robust base layer.
So what does building domain intelligence from logical primitives actually mean? What are logical primitives? Can you give us another analogy?
Absolutely. Think about teaching chess. Instead of showing a computer millions of games and hoping it figures out the rules.
Which is kind of how current AI often works, right?
Yeah, often, yes. Instead, imagine first explicitly teaching it every single rule. How each piece moves, checkmate conditions, how they interact, the fundamental building blocks. Only once those logical primitives are deeply understood do you show it games. You build the intelligence from the ground up based on core, verifiable logic.
Okay, so applying that to AI.
It means moving away from purely statistical models that just infer relationships from data, which can sometimes lead to, making things up or reflecting biases in the data. Instead, you explicitly encode the foundational truths, the axioms, the rules, the precise relationships of a specific domain directly into the AI's knowledge base.
Like for medicine.
Exactly. For a medical ANDSI, you might encode known biological pathways, drug interactions with precise dosages, diagnostic criteria as specific, machine-readable facts and rules. This ensures a deeply reliable, explainable understanding, not just a statistical guess.
Or for law.
Sure. For a legal ANDSI, primitives might be things like Contract A supersedes Contract B if signed later, or Party C is obligated to Action D under Clause E, precise, verifiable rules.
So this allows for efficient scaling within that specific area.
Right. Within a specific domain. As you add more verified information, new medical research, new financial regulations, the system integrates it logically and efficiently. It doesn't get bogged down. It just extends its robust internal model.
And the big benefit here is?
Reliability and interpretability. If we connect this to the bigger picture, this is critical for AI in high-stakes fields. Instead of just giving an answer, it can explain why, tracing it back to those foundational principles. It's about building intelligence with integrity, combining symbolic AI ideas with modern neural nets.
Okay, so what happens when you put these 3 things together? You've got the AI architect, ASI-Arch, the tiny abstract reasoner, HRM, and the bottom-up knowledge builder, knowledge graphs. This isn't just 3 cool things happening separately. You said there's a synergy.
That's the key. The synergy creates this incredibly powerful dynamic feedback loop. The ASI-Arch, the architect, can design optimal HRM structures, those super efficient reasoning models tailored for specific tasks.
Okay, so the architect builds the perfect mini-brain.
Kind of. And then these optimized HRM structures get refined and enhanced using Princeton's bottom-up knowledge graphs. They get imbued with that deep, reliable domain knowledge.
Making them experts in their narrow field.
Exactly. An incredibly potent combination. And the crucial outcome, the really transformative part, is that this enables rapid self-improvement loops for ANDSI agents.
Self-improvement loops. What does that mean in practice?
It means they don't just learn in the lab over weeks or months. They can adapt and get better in real time while they're actually doing their job, constantly optimizing their own architecture, refining their reasoning, enhancing how they apply their knowledge.
And they do this efficiently.
Yes. Crucially, adapting in real time with less compute than ever before. That inherent efficiency is a monumental game changer for actually deploying these things. It moves sophisticated AI out of just huge data centers and potentially onto edge devices, making it way more accessible.
Real-time adaptation with less compute. That is revolutionary. Opens up so many possibilities. And here's where it gets genuinely fascinating. The sources give concrete examples, critical areas like medical diagnostics or finance, fields where accuracy, efficiency, continuous improvement are absolutely non-negotiable.
Life or death sometimes.
Exactly. So how do these agents evolve to expert accuracy without generalist bloat? What does generalist bloat actually mean in these contexts?
Generalist bloat is a great term for it. It's the inefficiency of using a massive LLM, one that knows about poetry and history and coding slang, for a super specific task.
Like diagnosing one specific type of cancer.
Precisely. The big model carries tons of irrelevant knowledge. Its architecture is built for breadth, not the pinpoint depth needed. This means inefficiency, higher compute costs, and often it struggles to hit that near-perfect accuracy you need for diagnosing a rare disease or spotting complex financial fraud.
But ANDSI agents avoid this.
Completely. They are purpose-built and continuously refined only for their specific task. No bloat. And the source highlights that these compact ANDSI agents can outperform experts in tasks at a fraction of the cost and energy. This isn't just a marginal improvement, it fundamentally changes the economics of specialized expertise.
Can you give us a practical scenario, like in medicine?
Sure. Imagine an ANDSI agent specializing in, say, early detection of pancreatic cancer from scans. With every new scan it analyzes, it does the diagnosis using its knowledge graph, but it also learns and refines its internal model based on outcomes, new research, constantly improving its accuracy, minimal energy use. It becomes an unparalleled expert just on pancreatic scans, way beyond a generalist AI.
In finance.
Same idea. In ANDSI spotting insider trading patterns or credit default risks. It learns continuously from market data, new fraud tricks, updated regulations. It doesn't need to know about, I don't know, celebrity gossip. Its focus is absolute, allowing it to adapt and refine at speeds impossible for humans.
So this combination, this synergy, it's a real leap.
It really is. What's fascinating here is that this convergence marks a profound leap in AI. It truly allows that pivot from bulky LLMs to compact NDSI agents that are self-improving, hyper-efficient, and incredibly powerful in their niche. It means sophisticated AI isn't just for the giant, expensive, generalist models anymore.
That pivot completely changes the game for specialized uses, making them efficient, not resource hogs.
Yeah.
Okay, let's broaden out now. Look at the bigger implications, the near future. The sources say these ANDSI agents are set to accelerate the 2025-26 Agentic AI revolution.
So for you, the listener, what does Agentic AI actually mean in practice? We're moving beyond AI just answering questions, right?
Exactly. Agentic AI means AI systems with some autonomy. They can proactively initiate actions, monitor things, work towards a goal within their scope without needing constant human input.
They take initiative.
Right, and the arrival of these super efficient ANDSI agents directly enables what the sources call the democratization of deployment through these efficient tools.
Democratization, meaning not just the big guys get to use them. Precisely. Advanced AI agent capabilities won't be confined to the tech giants with huge budgets. Smaller companies, research labs, startups, maybe even individuals, could deploy sophisticated AI agents without needing massive hardware or cloud bills. It dramatically lowers the barrier to entry for using cutting-edge AI. It should foster a lot more innovation.
And their low energy use is key too.
Hugely important, especially for developing multi-agent systems for decision-making. Imagine not just one specialized AI, but teams of them, each an expert in a subdomain, collaborating autonomously on complex problems.
Like a digital expert committee.
Sorta. For a big company, maybe one agent tracks real-time logistics, another forecasts the market for one product, a third handles trade compliance, a fourth watches competitors, all working together, sharing insights, coordinating decisions to optimize strategy. Their collective intelligence, specialized and always improving, would be a formidable problem-solving force.
So where will we see them? The sources mention automation, service, healthcare.
Those are prime examples. Let's think about some plausible scenarios for you, the listener. In automation, maybe intelligent quality control on a factory line. It doesn't just spot defects, it learns why they happen, tiny variations in material, temperature. It refines its detection in real time and suggests process improvements, pushing towards self-optimizing manufacturing.
Okay, what about service?
Imagine hyper-personalized customer support agents, but super specialized, for troubleshooting one specific smart home device or handling complex questions about one type of investment. They learn from every interaction, getting better constantly, maybe even spotting issues before they become widespread. An incredible level of support.
And healthcare, you mentioned diagnostics.
Yeah, diagnostic assistance constantly improving. An ASI focused on early-stage oncology might flag scans, but also cross-reference with research, patient genomics, clinical trial updates. It could give a nuanced probability with detailed reasoning, helping doctors make better decisions faster. It could even track a patient's treatment response, refining predictions just for them. A personalized digital co-pilot.
These examples really show how these agents could overcome barriers, boost reasoning, drive adoption, growth, and innovations. They're not just tweaking things. They're enabling totally new possibilities, new business models, levels of precision we could only dream of before. Which brings us to the core point. This convergence catalyzes a new era of autonomous tools redefining knowledge work across sectors. It's not just augmenting us, it's fundamentally reshaping intellectual labor.
And this raises an important question for you, the listener. What exactly does redefining knowledge work mean for you, in your job, maybe even personally? Historically, knowledge work involved deep analysis, data synthesis, pattern finding, decision-making with complex info.
Right, the stuff humans are good at, or we're thought to be uniquely good at.
Exactly. But this shift means many of those tasks, especially in well-defined domains, can now be done faster, more accurately, more efficiently by these specialized AI agents. So think about a financial analyst. Instead of spending days sifting data for anomalies or risks.
They might oversee an ADSI doing that in seconds.
Right, and doing it more accurately. The human expert then focuses on interpreting the implications of those findings for strategy, developing new ideas, handling complex client relationships, things needing creativity, empathy, foresight, things the AI can't do yet.
Or a radiologist.
They might collaborate with an ANDSI that flags suspicious scan areas with super high accuracy, maybe catching subtle things a human might miss. This frees the human expert for the most complex cases. Patient interaction, integrating the AI's findings into a holistic patient view.
So the human role shifts.
Profoundly, from doing the rote analytical work, even complex analysis, to overseeing, guiding, training, and collaborating with these AI teammates. It elevates the human role to meta-analysis, creativity, ethical oversight, strategic direction. It pushes our expertise up the value chain, focusing on uniquely human skills. Hashtag tag outro bit.
And that brings us towards the end of this really insightful deep dive. We've explored the rise of these incredibly small, focused, rapidly self-improving AI agents. They promise to be faster, cheaper, and potentially way more accurate than the big generalist models we have now, especially for specific, narrow tasks. This isn't just a small step. It feels like a fundamental shift in AI's direction, how it's built, deployed, and how it's going to weave into our world.
And this leads us to a fascinating, perhaps provocative final thought for you to consider. How will the widespread deployment of these highly specialized superintelligences, which can reach and keep improving on expert-level accuracy in their narrow fields, how will that actually change our whole understanding of what expertise is?
If an AI can master a field so completely, so efficiently, where does human value lie?
Exactly. Where will human value and innovation truly lie? Think about how entire industries, traditional job roles, might have to evolve when hyper-specialized AI teammates become common. Not just assisting us, but autonomously outperforming us in specific analytical and decision-making tasks within their domain. This is really just the beginning of understanding the full impact of a world filled with these intelligent microagents. And it raises some profound questions about our own roles in the coming knowledge economy.